Hello, everyone. Thank you for joining today's webcast. My name is Zina Pagan, ARF's Marketing Manager, and I will be your moderator for today. Before we begin analyzing our social networks, I will go over a few items. For the best webcast experience, please keep yourself muted and your computer web camera turned off. Unfortunately, if you do turn on your cameras or unmute yourselves, I will have to disconnect your access to today's webcast. The audio will be streamed. This means that you will be able to hear us throughout your computer speakers. However, if you prefer to use a teleconference option, you can use the information that is on the slide in front of you, or I will post this throughout the webcast in the Q&A section. Should you have any questions during the session, please send these to me using the chat box. ARF does not own the rights to the presentation. The session will be recorded. If you would like to view the recorded event, the file will be available within 2 weeks from today. We are extending the conversation on social media. If you'd like to join us, please use the hashtag ARFwebcast. If you're interested in hosting a webcast of your own, please contact me at zina@thearf.org. We are hosting several events throughout the fall. Actually, if you're in the Chicago area today and you are a young pro, we have our happy hour later this afternoon. Our next webcast will be September 21st, and we will feature our very own How Advertising Works, the Neural Pathways to Great Creative. Also, for the first time ever, the ARF will visit the Helen Mills Theater here in New York City with our Maximizing Mobile Creative event on September 22nd. The full-day event will feature C-suite participants from Bartle Bogle, Hegarty, KBS and Partners, Neuro Insight, Nielsen Consumers, Neuroscience, and Verto Analytics. If you're interested in any one of these events or other ARF programs, please check our website or contact me directly. And without further delay, I present to you Michael Lieberman. Michael, take it away.
And ready? Let's see. Okay. Are we good, Zina?
Yes, you're on full screen. You're perfect.
Okay, good. Hi, everybody. Welcome to Visualizing Big Data, Social Network Analysis. We're going to be doing a few things today within our 45 minutes or so. I'm going to start out a little bit differently than I normally do. I normally go right to the background, but instead I'm going to give you an example of network analysis and its an application. Then I'm going to go to a little bit of background of network analysis and key outputs. And from there, I think we're going to hit the meat of the presentation, which are, the examples which are used directly in advertising research through a couple of social network examples. And finally, I'll take some questions on application and the sort of studies that these might entail. Okay, so let's begin. I gave a different webinar, it's a bit longer, but I put the first few slides in there, and I would start this webinar by asking how many people in the room remember the Columbia Music Club. And I know it kind of dates us, but it's true. And people will raise their hands. I raised my hand when I was a kid. The Columbia Music Club would send you a card saying this is the album of the month, and if you didn't return the card, they would send you the album, and that is called a negative default. Now, that has since become illegal to do that. However, nowadays, when you're working on Google or Android or Apple, you are actually using negative defaults all the time. Now, for Google, they have literally thousands and thousands of apps. What they do is they have thousands of apps. They have 189 different permissions. And then what they do is they segment their apps by what they think is type. And for this example, to show you how to use network analysis, I looked at the Gmail quote-unquote segment of Google Apps. And here's a few examples of what's in that segment. Firefox browser, Android, Outlook, things you've seen before. And what we did was we took the data and we put it into a network analysis map. And looking at this network analysis map, and we're going to be moving on a little bit later to behind the things and using these sort of maps for social network analysis. The first question is, well, are Google, they clustered Gmail together. Does the cluster hold up under network analysis, which is applied graph theory, and then a clustering technique within the cluster analysis? The answer is no, because if you look at the map, you see 4 different colors or 4 different questions or 4 different groups. Now, these are important later on when we're looking at Twitter data or Facebook data, because we're going to see different groups of people. But we have 4 different groups, and you can see what they are: SMS, Outlook, Gmail, Viber, security, Google, Facebook. This is an application of network analysis. The second thing we want to look at is not so much the most popular nodes or the largest ones, but the smallest ones, the ones that are in isolation. Now, I'm going to get into eigenvector centrality a little bit later in the presentation. What we wanted to look at was the isolated nodes. And here's an example of some of the isolated nodes. This output is going to look similar to some of the output that I'm going to show you a little bit later, but we look at the isolated nodes, and then we saw, well, what are they connected to? So if you have Yahoo Mail as an application on your phone can read your sensitive log data. Outlook.com reads your frame buffer. Now, what does that mean? That means that it takes a picture of your phone every 30 seconds and sends it back to Outlook.com. BlackBerry Messenger can read your confidential events and calendar. And then if I was in a room, I can't see any of you, but I'd say, okay, Melissa, is that okay with you? And she would say, well, no. I said, John, are you happy that Outlook.com takes a picture of your phone every 30 seconds and sends it back to Outlook? And he said, no. And I would say, well, why not? You agreed to it. That's called a negative default. We were able to tease these out using network analysis. Okay, it's a very powerful technique, and given that a lot of the software now is open source, it's not that hard to get. Now, a little bit of background network analysis. What we're going to go do for the rest of the webinar is use this sort of analysis using social network data. We're looking for structures of data within Twitter, within Flickr. We're looking at what's being said, and we're using classification methods to say that. Okay. The first social network, the first network analysis that I found, and I did some research, was a drawing by Jacob Marino of 1934, and what he did was he drew out an American sports team, an American football team. And if you look closely, what he did was he has the nodes are each player, and the lines are their relationship to other players on the field. And this, in essence, is what network analysis is. What we're looking at a network, the people who are involved and the relationship to other people. And then what we're going to be doing is teasing out the meanings and what it has to do with our client/project. Network analysis is used in a number of different industries. It's used very commonly in engineering. I've seen a lot of it in economics, criminology, construction, bridge building, believe it or not, with Monte Carlo analysis. So using a lot of network analysis, because if you're building a bridge, you want to know that the first phase is done before the second phase begins, and you need to use network analysis and Monte Carlo analysis to estimate the time of the first part of the bridge before the second bridge begins, because the second bridge costs $2 million a day and you don't want them sitting around. We just passed 9/11, and what you have in front of you is a network analysis map of a terrorist who committed the 9/11 acts. Excuse me. This is once again a common use, and any of you who watch, like, for example, crime television, you know, they have the relationships. That itself is network analysis. This map was created by the NSA, communications of who was what and where and what they did. All right. So the question then becomes, why employ network analysis? And here are a few of just the background things that you can get out of using this particular technique. You want to understand your network, what's being said. You want to identify influencers, and that's very big on a small level or at a large level. For if you want to know, if Susie speaks to Jen and 1,000 other people, then you want to give Susie perhaps a coupon, or if you have a social network media influencer who are concentrating on various things. There's a lot of those out. Forbes has a whole list. For those of you who have to present to clients or C-suite, network analysis allows you to visualize your data in a way that makes it very easy to understand. And I found that to be a tremendous advantage, because I get up there and I show my map and I run through it and my clients understand it. It shows you the information pass for branding research, campaign effectiveness, and that's good if like you're putting together a presentation or you're doing research, you want to know how the information flows, you can use this particular technique. Okay, for social network analysis, on your left are the major sources of data for social network analysis. Now, most of you have seen these: Twitter, Facebook, YouTube. There is one which is probably not super familiar, and that's the Vassan network. The Vassan network allows you to plug in a website and then to track all its inbound and outbound links. We're going to touch on that in a little bit more detail later in the presentation, but that's actually a fairly effective way to get a look at, say, how an industry is set up, or if you have a client website, who's linking into them and why, and who are they linking into, and you get a whole idea of how the whole network itself is set up. Just a little bit of mathematical background. We're not going to go into this much. I am a statistician. After all, there are four degrees. There are four measures which you need in network analysis, which is applied graph theory. Two of which are really important, and two of which you should know. You can see the important ones, and I have them down on the lower slide. Degree is how many people a person knows directly, and the eigenvector is how many connected people does your connected person know. The other two are not, they can be important, they're not as important in social network analysis, because we're looking at overall conversations, not necessarily conversations in, say, if you're investigating a company and you want to see their email, or if you want to check the speed of a communication. Here is really what you need to know when you're doing a network analysis. People tend to group on social media, and in those groups there are center or centers of the group, and the software measures the degree of how many people are connected to the group. I call that popularity. Okay, that's important. The second one important is called eigenvector centrality, and I learned this particular software at a predictive analytics conference in San Francisco a few years ago, and the person who gave it to me, my mentor in this particular technique, his name is Mark Smith. He said, if you stand on the street corner in San Francisco and scream eigenvector centrality, then venture capitalists will come running up to you with a check. And the reason he said that is because eigenvector centrality is the central theorem behind Google. Now, I tried that. Unfortunately, I did not have venture capitalist people running up with checks, but I did get arrested. And if we were in a room, hopefully some of you would smile. Eigenvector centrality is a person who might be connected to several groups, and a bridge person. And that somebody is really important to know, because if you give the bridge person the message, he's likely to spread it across several different groups. This is also applicable for supermarkets. If you have a bridge item, people tend to buy items in groups: hot dogs and mustard, cereal and milk. But you might have an item, and you can put sales data into network analysis, and then you can find out who has the highest eigenvector centrality or the highest bridge value. And for example, turkey breast is one of them. And I'm going to show you a map at the end which shows an example of this. But you know that if you put turkey breast on sale, it will spur sales across different categories in the supermarket. So that's what you should put on sale. With regards to social network analysis, the person with the highest eigenvector centrality, along with the person with the highest popularity, is what's known as an influencer, and that's important. All right. I use something called NodeXL. NodeXL is an Excel background. It used to be free. Now he's charging a nominal fee. And this is a screenshot of what it looks like to gather data from social network using NodeXL. And as you can see on my right, if you look down, you can see the various sources from which you can get the data: email networks, fan pages, of course, Twitter, a list network or a users network. Twitter makes it very hard. A user's network, because if you look at a user's network and say they have 100 followers, which is not a lot on Twitter, and those people have 100 followers, that's 10,000 followers. Now that's a lot of data to download, and Twitter limits you to a certain number per 15 minutes. So when you try to do a user's network and you put in like one person, another person, it stops. And then you have to wait 14 minutes, and then it starts again. And then right after that, it kind of cuts you off. We can do Web 1, which are web pages. This is a rather old slide. There are other things we can do now with Flickr, and my daughter is much more familiar with all the different social networks than I am. I tend to stick to Twitter, Facebook. I do some research on web pages. But this is what gathering the data, this is a screenshot of what it looks like. All right. A summation of network maps basically is they represent social networks. They are visual, and we're going to see several of them in the next section of the webinar. We want to identify key nodes, and if you look over to the left, key players and influencers. That's the really important stuff when you're doing this kind of analyses. These are the kind of things if you're writing a report and you want to put them in the executive summary, then you put the key players, the influencers, and then later on, a little bit later on, how you got to them. There are 4 measures in a network map. Okay, the first, if you look up to the top right, is a bridge. It's probably not a shock, given that the person who developed the software is from San Francisco, that is the Golden Gate Bridge. Down below are crowds and clusters, very common in social network analysis. The hubs are the eigenvector centralities, or the center people. In other words, the hubs are usually within the crowds and clusters, and then we have the islands. And the islands are people who are talking about a certain brand or talking about a certain subject, or not necessarily connected. They can be very important to your brand. And I will show you an example of that as well. All right, we're going to start off with Twitter. There are 6 kinds of Twitter social media networks. And I'm going to run through an individual example of all of these, except for one, most of which were actually created today. You have a polarized network, the InGroup. The only one I'm not going to show, the bizarre, which is, if you notice, it's not bizarre as in weird, but bizarre as in market. Broadcast map, if you're looking at a television station. The only one I'm really not going to show is the support one down on the bottom lower right, because that's not all that applicable to the kind of work that we do. That's more if you are a Dell support center and you want to track who you're supporting, then you would use that kind of map. And that I haven't found in marketing or marketing research that's a particularly common map. Okay, we're going to start with polarized 2 dense clusters. And this is an old map, but I think it's very interesting. This map was made back during Arab Spring in Egypt. And what's interesting about this particular map is a woman named Mona El-Hawi was a blogger and a Twitter person back in 2011. And the reason I still have this map is because I haven't found a better one. And she was tweeting about bringing down the government of Hosni Mubarak. And at the same time, she was tweeting about women's rights in Egypt. Now, interestingly enough, a lot of the people who were following her or answering her were supported Mubarak, but they did not believe in women's rights in Egypt. And these kind of maps are created when you're bringing in Twitter. The Twitter maps, they're created by taking the tweeting, who's tweeting what, who's connected to who's retweeting. You put them inside the software creates this particular map. This is a template that I got from Mark, which I'd be happy to give to anybody else. The learning curve on NodeXL is fairly steep, but once you have it, you have it. And if you know how to do any data analysis or data planning in SPSS or something like that, you can shape the data to put it in these kind of maps. So what we're looking at is a map of people who Mona Al-Hawi was tweeting, people were answering her. The software gathers in the tweets and the retweets, puts it into the map, and this is what we have. So what we have on G1 are people who, feminism, Egypt, Middle East. When you're reading these kind of maps, when you're reading any Twitter map, the clustering of the hashtags really tells the story of a particular group. So the power of a Twitter map might be how many people are talking about it, the clustering of people, and then the hashtags. And we're going to see several examples of this. The hashtags and how they group gives a summation of what they're saying. So here in the polarized map, we've got people to the right, to the left, who are agreeing with her, and people to the right who don't agree with her because they're against Mubarak, but they're not for women's rights in Egypt. So this is a terrific map. All right, moving down, this is an in-group or community map. These kind of maps are very useful if, say, the ARF, and I tried to do one for the ARF this morning, but given that if we were at an ARF conference, I could produce a really good map. But unfortunately, we're in a time when there hasn't been an ARF conference, so there wasn't much out there. So the MozCon conference actually happened, I believe it was yesterday, day before. So I ran this map this morning, and what we're seeing are people who attended the conference and what they have to say about the conference. So this is a very interesting map because if you have a group or a conference going on, or you have a particular hashtag, you can actually focus it on the hashtag and run the group and see what they're saying. Moreover, and I don't have time to show you this, the output in the Excel file shows you every individual tweet that was made. So with an in-group tag, and I do this, by the way, when I attend conferences, I create maps for the conference I'm in, and I give them to the people who run the conference. I believe I created one for the ARF back in the spring. So these particular groups give a really good idea of who's talking and what they're saying, and you get all the Twitter people in the output of the Excel file once you've run the map. Okay. The next example, and a very common example, is what's known as a brand or public map. Now, these maps have a characteristic. If you look, map was created this morning. BMW is one of these brands you can always create a brand map for. But these kind of maps, if you look at the various hashtags, you can see what people are saying about the brand. Now, this one isn't that great. Top stories, Nation Entertainment, G7 toward the middle and the bottom, BMW Moto. I did a few of these for Audi, where it said BMW and Audi and other things. So if you have a brand and you run a map like this once a day for 30 days, you really get a good idea of what people are saying about your brand. Now, what's most important, I think, about brand topics is brand maps is that if you look over to the left, for brand maps, a really big characteristic of brand maps, particularly large brands, is that there are a lot of islands. There are a lot of people who are talking about a brand who are not connected to other people. The reason this is interesting is because if you have a brand and you run a map, you get amongst the output everybody who says anything, and so you can see who the islands are, and you can see what they're saying, and some of them might be worth contacting if you're the brand, even though they're not in a large group. And that is the usefulness of a brand topic map. Sometimes when something bad happens to a company, I shouldn't mention names. If you're a car company and you have a massive recall of, say, airbags, you run these kind of maps, and all of a sudden the recall comes up, and you can dig down to see what people are actually saying about the recall. You run the map every day for 30 days. You see if the mood is changing, and what are the independent people saying. It's another type of map. All right. This is a bizarre map, as in market. I ran this one this morning, and this one has very different opinions on it. I'm sure most of you, and you can just show me by hands, have heard of Hillary Clinton. If you map her Twitter feed, you get a lot of different opinions. And these kind of maps tend to have a lot of smaller, different groups. So if we look at group number 1, we look at the clustering of the hashtags. We see DNC Leak, In With Her, Never Hillary, Colin Powell, Thanks So Much Obama, Crooked History, Hillary. Okay, so that group is well, we have to dig down a little bit. Is that pro or anti-Hillary? But we're going to get a lot of different opinions on a bizarre map, not just two, like in a polarized map. I'm going to show you some output from this particular map a few slides down, and it's actually kind of funny because in the different groups, the hashtags and the keywords, you can really see who's who. A broadcast map is if you are looking at, say, a news source, a website, CNN News or Mad Magazine. Actually, Mad Magazine makes pretty interesting Twitter maps. I've done them. The RAND Corporation is another one. I chose this morning Slate because Slate is a political magazine, and we can see by the hashtags, broadcast maps, because we're looking at a particular like media outlook and their output. They usually have one dominant cluster and several smaller ones. And if you look at G1, you see the clustering of the hashtags. You have an idea of the top stories in Slate. Dear Prudie, I don't know what that is. Slate is probably running stories on the DNC leak, Trump, Hillary's health, tourism. How you get. I believe there was a story about Trump paying off the Florida Attorney General. That comes in a bit later. And that comes over to G number 3. We have Trump, MAGA, Obama in with her. That is people who are responding to Slate saying, you know, Trump was doing this, Trump was doing that. Broadcast maps are very useful if you want to see, if you're doing like the New York Times or CNN, or I've done some in France, and you want to see what's being broadcast on a particular media outlet or anything. It could be a political candidate and his Twitter map. Okay, this is an example of some of the output which you might find in a Twitter map. I've obviously taken them out. This is the one that I ran this morning for Hillary Clinton. And if you look at G number 1, which is our column all the way to the left, the most common hashtags in tweet and graph number 1, because remember, we are pulling in tweets, we are grouping them, and then we are classifying them, and the tweets themselves tell the story of what's being said within the group. Okay, so DNC leak, never Hillary, Colin Powell, thanks Obama, crooked Hillary. It's kind of a mixed bag there. Pay to play, Hillary's health. Okay, it looks to me like not particularly pro-Hillary, but if you look down, another output are the most common word pairs within a group. Hillary, Donald, allegedly paid, Trump's foundation allegedly so, Florida's attorney. So drilling down on this particular map on Hillary Clinton, group number 1 might seem to be anti-Hillary, but not so much, because we're seeing a lot of mentions of Trump and the Florida Attorney General. G4, group number 4, which is the middle column, that to me seems like a very pro-Hillary people. Pay to play, DNC, blue state, Trump business, moms demand Hillary. Looking down at the word pairs, we see Hillary, all positive Hillary, Hillary POTUS, POTUS Hillary, Hillary Donald. Now, if you were really going to use this map, you have the output gives you each Twitter person by group. So if you wanted to contact people who are pro for you or anti for you, it can be done. It's a little bit like text mining. It's a little bit labor intensive, but it can be done. Okay, we look at group number 8. Finally, I think we're looking there at a very pro Trump, because we're looking at corruption, corrupt Trump, Pence, Hillary for prison. Doesn't sound to me like a pro Hillary hashtag to me. And looking down at the tweets, we see Fox Business, critics fired Hillary's email, anti-Hillary things. So this is an example of output from a bizarre map. Each of the maps that I ran, by the way, have output like this. It's just that this is the one that I chose to show because it's actually the most fun. All right, we're now moving on to Facebook. Now, the problem with Facebook, or the challenge with Facebook, is in order to mine Facebook, you need to have the person's password. Now, I don't use Facebook on a professional level, and the only password I really have is mine. So what I did was I downloaded my my contacts or friends in Facebook. and I ran a map on them. Now, a certain thing you need to understand, a 1-degree map is a person, if you're looking at a Facebook person or a Twitter, 1-degree map is that person and everyone they're connected to. A 1.5-degree map is everyone who's you're connected to, and they're connected to each other. And a 2-degree map is everyone that you're connected to and everyone they're connected to. For Facebook, NodeXL gives you a 1.5-degree map. So I'm looking at the people I'm friends with and if they're friends with themselves. They're friends with each other. And when I ran the clustering algorithm, it really came out very robust. Look at that, because I mostly use Facebook to catch up with friends I went to high school with. For those of you who can read the number 1982, you know how old I am and how long ago I graduated. But if you look down to the right, all the way down to the right, you see a couple of people. Ristorante Alfredo, 1986. I worked in Ristorante Alfredo as a senior at Rutgers University, and I'm friends with a couple of people who worked there too, and the software was robust enough to find that group. And so it's good in that case. I would use Facebook if you can get the password. However, as you can see, you can also look at someone's likes page or on Facebook. The problem is, as you can see, and this was Starbucks that I ran recently, it's huge. It's got a huge amount of unique edges. I think I'm okay on time. I need to move up maybe a little bit faster. And the problem with this is it doesn't really give a lot of information. Likes. This is not the best software to do Facebook likes pages. This is a good software to use if you have a local client who has a Facebook page and they'll give you their password. Then you can find the influencers and give them for example, a coupon. It's pretty easy to do. You have to get the password. Okay, with regards to Facebook likes pages, it's just so large and these people are just not connected to each other. And I ran this thing and I just sorted on between centrality and eigenvector centrality. Between centrality is a popular message. Okay, so there's a lot of here. It's kind of an open source. As I said, for Facebook, what you really want is the password, not so much the likes pages. Okay, moving along. And my final social network category is mapping hyperlink networks. Okay, there is a ton of data being created on social networks, but it's been my impression that the most stable are web pages, and web pages can be used very, very effectively if you're looking at a brand space and if you're looking at to see, who's connecting to your website. The data comes from Vasan, which is it's an online crawling method. It's completely legal. I have a free subscription, but if you're doing this for a client and you want to do a lot of different networks, it costs like $50 or $100 for the subscription, and then you can download all the links and you can look at which web pages are connected to the other web pages. I did one, and I want to show you because this one actually is pretty interesting. I did this for the ARF this morning, and this is once again a 1-degree map. In the middle is the ARF, and the nodes represent every single web page which is connected in to the ARF, not the ones the ARF is connected out to. And you go to Vasan, you put up, this is the website I want to look at. 15 or 20 minutes later, you get an email saying, okay, we've crawled it. You bring it back into NodeXL and you run the map. This is a simple ego map. It doesn't mean that the ARF has a huge ego. It means there's only one center. These sort of things can be useful. We did one of these a few years ago for New Girl. And this is the ego map of New Girl, the website. Chloe apparently is what's known as a hipster or something like that. And we got a lot of different types of people who are connecting into the New Girl website. And what we did was we put them in a pie chart to see who was connecting. And it's kind of surprising. Now, the largest ones, TV networks, affiliations, celebrity magazines, and fans, that's to be expected. But if you look down on the purple, on the sort of in the middle, it says fashion design, 10%. Well, I don't know. I've only watched New Girl a few times, but she doesn't seem to me to be a fashionista. And you look up top to the a beige slice, DIY crafting and cooking, 6%. Now, why would those kind of websites be hooked into the New Girl website? It's because the star, whose name I cannot remember, appeared on a DIY show for Thanksgiving for DIY crafting, so they connected into the New Girl website, and as a result of that, that showed up when we ran the Ego Network. So when we reported this to New Girl, they were surprised to find out that all these people are connecting into the website from DIY websites because Chloe appeared on a television show. Now, this is a hyperlink. This is the way to build these kind of maps. Is you start with one website and you can build out. You can look to see who they're connected to, and then you can say, okay, well, this looks like interesting, and you put other networks in to crawl, and you kind of build it out to a 1.5 or 2 degree network. This is an example of the marketing research industry. I started, and I believe the ARF is in here somewhere. You start off with a couple of key websites and you see who they're connected to. And it makes a lot of sense. So Kantar World Panel is connected to WPP, who I think Kantar owns, BBC News, Kantar Shot, the PMRG.org, and the Kantar Health, IOI, it makes a lot of sense. Now, this can also be a little bit more useful for casual dining restaurants. And this is, I believe, our final slide. I put in the name of several popular websites for the casual dining industry. I do quite a lot of work in this field, and I wanted to see what was connected to who. And some of the stuff can be very interesting. If you look over to the right, to the left, you see a blue circle with the Cheesecake Factory, and then you see like some of the websites connected to the Cheesecake Factory. I wanted to say that the proximity of a node to other nodes in this case does not make any difference because I pull them out. There's no, okay, it's just everyone has a degree of 1. The Cheesecake Factory, Craigslist Rochester. Now, why is Craigslist Rochester connecting to the Cheesecake Factory? Because when I ran this map, Cheese Factory had just opened up a franchise in Rochester, and they were advertising for workers. You have what you do on these sort of things. You look in the middle of the map, and you see Money Talks, News, Salt Lake Magazine, and all these people. My Fox New York, Kids Eat for Free. These are media outlets, web pages who connect into different restaurants and give them reviews. And the final point I want to make is if we look at the green Applebee's.com at the bottom, you see all the way at the bottom to the left, NHL Red Wings, Applebee's, and CNN Health. Okay, now P-Interest, Applebee's. So why is it that the Red Wings and the Applebee's are connected to the NHL Red Wings are connected to Applebee's? And the reason was because Applebee's did a co-branding with the NHL Red Wings at the time this map was created, saying that if you go to an NHL Red Wings game, you get a reduction on your Applebee's dinner before the game. Okay. Finally, this is an example of, as I was talking about before, it's kind of a small example of if you put in sales data from a supermarket, the size of the node is actually the eigenvector centrality, or the bridge. So when you're looking at this, we're looking for the largest bridges. Different colors are the different categories of things you might buy. And the one with the largest eigenvector centralities, or the largest nodes, are the ones you want to put on sale. So we see at the top, for example, hot dogs. Now, hot dogs are a very popular item, but they have a very small node because they're not connected to much. But turkey breast is a very large node because it's connected to the green, the light blue, and the blue all three of the various shopping clusters. And that's interesting because if I was going to take sales data from a client and put it into network analysis, what you're essentially doing is clustering, and you're telling, what you do is you would advise your client, put turkey breast on sale, put whole wheat bread on sale. And with that, we are finished.
Hello, Michael. Can you hear me?
Yes, I can.
Okay, great. I do have a few questions. First question, can you mine and analyze other social media apps such as Tinder?
Yeah, you can actually. But Tinder is actually a new one. It's funny that you should ask, because if you know what the use of Tinder is, what you would get if you mine Tinder is it's a hookup app. So you can kind of mine it, and then you can sort of see who's hooking up with who and how many. And so I'm not sure what sort of deliverable that would be to a client or who would hire me to do that. But yes.
Okay. Second question, what is the most common types of Twitter network analysis sold to advertisers?
For Twitter network analysis, we do a lot of brand and network, or network maps, where you have the central thing. Those kind of projects are common if, say, an advertising firm puts out a campaign and they want to track the campaign on Twitter, on Flickr, or whatever it might be over a 30-day period. So what they would do is we would run a map every single day of that particular hashtag, and to see how the conversation changes, over a month or over 45 days, whatever it might be.
Next question, can you give us an example of how to build a brand space by mining hyperlinks?
Yeah. Yes. I will give you an example. For example, if you have your client is in the aluminum industry, say Alcoa, you you would first go and you go to the Vasan, and you would say, okay, look at Alcoa, and then you'd also put in as a seed site Alcoa's competitors, and then you run it and you get all these inbound links or outbound links. And then you would look it over and say, that's an interesting link, and you add that to the seed sites. Oh, that looks like an interesting link. You add that to the seed sites. This is a process that might take a while, several days, even because what you do is you're building out the connections to your brand, to your competitor, and to who they're linked to, and then who they're linked to or linked to. And then as you build out the map from the websites, you are actually creating a brand space, or what's going on in the web in that particular industry.
Next question. This particular person missed the introduction, so he'd like to know, what do we do with these 6 types of Twitter networks?
Well, there are different outputs for them. I mean, for example, and can you see my screen still?
No.
Okay. What
If
you
you'd
really
like to share it again, don't worry about it.
Sure.
You can do it.
Okay, hang on. Essentially, what you're doing there is you're looking at hashtags, and the different types of maps result from the hashtags. So I think the question really is, what type of map am I getting out of my hashtag? And a hashtag could be here. I'll just bring that up. Okay, there we go. You all see that?
Yes.
Okay, good. So we have, like, say, and your hashtag could be something political, like Black Lives Matter, or what is Aleppo. That was actually a pretty good map a couple of days ago. There is a NodeXL gallery where Mark Smith, my mentor, puts up a lot of different hashtags for, Asia Core, women's rights. I did a couple for the Chicago School Board. If you are following a particular media outlet, then you might want to do broadcast maps. That's that. In general, these maps come from different types of hashtags, but usually you let the software create the map itself, and then you see what kind of map you have.
Same person, how are there different marketing implications by the types of network?
Absolutely, there are. See, that is more of a project-specific question. If your client comes to you and says, "Okay, I want to know who's connecting to my competition's website," that's one thing. As I said with Facebook, it's not the greatest thing for Facebook, but if you have a small client, a local bakery chain, and they have a Facebook page, and they'll give you the password to the Facebook, then you can identify different influencers. There's a lot of different applications to using network analysis. You can use network analysis for Netflix. You put in all the television shows, who's using what. You use SPSS or Excel to shape the data, and you can put it into network analysis, which is the same kind of map, only the input is television shows and not Twitter. And then you can see, well, what are the most popular and what are the eigenvector shows, and then you'd advertise. You would suggest to your client, this is where I think you should advertise because it's a bridge show.
Okay. Okay, Michael, that's all I've got for questions. Are there any last thoughts you'd like to share?
I would say this. There are, as I read a book years ago, and the book was called The Sovereign Individual, and the book was written in 1995. And what he said in the book was, as bandwidth expands, opportunity will expand, and we're seeing that now. Big data has been around. People say big data, but there are a lot of open source software such as NodeXL, which is not open source anymore, but it's inexpensive. That you can use, and you can use techniques which have been around for a while. Graph theory has been around for a real long time, but you can use them on an everyday practical level, and you don't have to be a PhD statistician to do it. I mean, it takes a little bit of a learning curve. So the takeaway I would have for this is add this to your wheelbarrow if you're listening, because this is a really interesting technique, and it takes about 5 minutes to explain. And if you can keep your client's attention for 5 minutes, you can give them a really good way to analyze their Google technique or their television shows, their Twitter feeds, all that sort of stuff.
Okay, thank you everyone for joining our webcast today. Special thank you to Michael for taking the time to present his study with the ARF to our webcast crowd, excuse me. I hope you all join us for next week's webcast on the neural pathways to great creative. Thank you everybody, goodbye.
Oh, hello?